Chemical reaction, a process in which one or more substances, the reactant, are converted to one or more different substances, the product. While to make it more further, chemical reaction is a process in which substances called reactants are transformed into different substances known as products by breaking and forming chemical bonds. It involves the rearrangement of atoms and the breaking and formation of new chemical bonds. The reaction is driven by the interaction of the atoms and molecules, and it can release or absorb energy. As we talked about the chemical reaction earlier, it mentions the reactant and the product. But what is the difference between those two? And how does the reactant and product connected to the chemical reaction? Well, the substances to the left of the arrow in a chemical equation are called reactant. A reactant is a substance that is present at the start of a chemical reaction, while the substances to the right of the arrow are called product. A product is a substance that is present at the end of the chemical reaction, and it is the result of the reaction. Combination or synthesis. A combination reaction is a reaction in which two reactants combine to form one product. This is an example of combination or synthesis. Next, we have decomposition. A decomposition reaction occurs when one reactant breaks down into two or more products. This is an example of decomposition. Next, we have single replacement or single displacement, also known as single replacement reaction or exchange reaction. It's a chemical reaction in which one element is replaced by another in a compound. This is an example of single replacement or single displacement. Next, we have the double replacement. A double replacement reaction occurs when parts of two ionic compounds are exchanged, making two new compounds. This is an example of double replacement. Next, we have combustion. A combustion reaction is a reaction in which a substance reacts with oxygen gas, releasing energy in the form of light and heat. Combustion reaction must involve CO2 as one reactant. This is an example of combustion. First, let us list all the symbols that we can find in this example. Well, as you can see, there are two symbols, the Al or aluminum and the Cl or the chlorine. After knowing the symbol, we're going to check if the reactant and product are equally balanced. In our example, the reactant is Al plus Cl2, which means our aluminum is equal to 1, even if it doesn't have a subscript or coefficient in it. While in the Cl2, the chlorine is equal to 2, because it comes with a subscript 2. Next, we're going to move with our product. In our example, the product is Cl3, just like in our reactant. The Al symbol doesn't have a subscript or even a coefficient in it, so it means aluminum is equal to 1, while in the Cl3, chlorine is equal to 3 because it comes with a subscript 3. After knowing the value of aluminum and chlorine, we're going to check if they are both bonds, and if they are not, we are going to balance them. In the symbol aluminum, our reactant is 1, just like in our product, so we can say that they are balanced. Next, we are going to check if the symbol chlorine is also balanced in our reactant. The symbol chlorine is equal to 2, while in the product chlorine is equal to 3, so they are not equally balanced. So to make them balanced, we're going to put a coefficient before the symbol, because it will be easier for us to balance if we insert a coefficient rather than a subscript. So the first thing we're going to do is the symbol chlorine, because they are not balanced. But how can we balance them since we can't make our Cl2 into Cl3? Because when we put a coefficient in front of the symbol, it means to multiply. So it will not going to be balanced if we put a coefficient 1, because it will be 1 multiplied by 2 is still equal to 2. So it will not going to be balanced. Let's try to make our coefficient 2. So it will be 2 times 2 is equal to 4. But now it is too much because we just need to get 3. So let's try to add the coefficient of 2 into our Cl3. But if we put 2 in front of the Cl3, the Al in the product will going to change since they are connected. But it's okay because We can easily balance Al in reactant even if the Al in the product changes, since the Al in the reactant has a value of 1 and it is separated from Cl2. So if our value of Al in the product is 2, just going to put a coefficient 2 in front of the reactant, Al. So it will be 2Al plus Cl2. Next is the product, Al. So to make them balance, let's also put 2 in front of our Al3, so that it will be 2AlCl3. So our product in our reactant and product are balanced. They are both 2. Next, let's move to Cl2 and Cl3. So the Cl in our product is multiplied by 2 because it is connected to 2Al. So it will be 2 times 3 is 6. So in order for them to be balanced, we need to put a coefficient of 3 in front of our Cl2. So if we multiply it, it will be 3 times 2 is equal to 6. So our chlorine is in our reactant is equal to 6. Next, let's check our product if it has the same value of our chlorine in our reactant. So since it has a coefficient of 2 and a subscript of 3, it will be 2 times 3 is equal to 6. And now, our example is equally balanced. The final answer is 2Al plus 3Cl2, 2AlCl3.
So as you can see in here, we have the reactant and the product. Now let's identify the following symbol. So here we have carbon, hydrogen, and oxygen. Now let's get the value of the reactant. So we have here the value of carbon in its subscript is 3. Next we have the hydrogen and the value of its subscript is 8. And lastly we have oxygen and the value for its subscript is 2. And the value of its coefficient is 5. So what we're going to do next is we're going to multiply the value of its subscript and its coefficient, which is 5 times 2 is equal to 10. So the value of our oxygen on the reactant is now 10. Let's proceed by getting the value of the symbol in the product. So we have here the carbon and the value of its subscript is 1. Next is the hydrogen and the value of its subscript is 2. And lastly, oxygen, and the value in subscript is 3. Now we're going to balance this given equation. In carbon, we have the value of 3 in reactant and the value of 1 in product. So we're going to choose the lower value, which is 1. So we're going to add 3 in here. So it's going to balance. So now they are balanced because as you can see, the value of carbon in the side of the product is now 3. Now let's proceed to the hydrogen. As you can see, the product here is much lower than the reactant. So we're going to focus on the product by adding a number that is balanced. So we have 8 in the reactant. So for it to go into balance, we are going to add a coefficient 4. So we have 2 subscripts. So 4 times 2 is equal to 8. So now they are balanced. And lastly, we have oxygen. Now let's check if our equation is already balanced. We have a coefficient of 3 and a subscript of 2. So 3 times 2 is 6. And the other side, you have a coefficient of 4 and subscript of 1 because a symbol is automatically have a coefficient of 1. So 4 times 1 is 4. So 6 plus 4 is equal to 10. So the value now of our oxygen is 10 and they are now balanced to each other.
Now it's your turn to balance this given equation.